I'll be honest, of all the things you do and all the companies you run, I think it's all awesome. The one thing that does concern me, and I know concerns a lot of people out there, so I do have to bring it up, which is Neuralink.
Sure.
So firstly, can you explain what Neuralink is and what the goal of it is?
We put a chip in your brain to control your mind. Yeah.
Okay. All right. Concerns not alleviated.
Yeah, there you go. Jump right in. Step right up. Who wants one? No, so Neuralink, you'll be able to see Neuralink coming from a very long distance, because any device that you implant in a human you have to go through so many tests. It moves very slowly. You just do a few people at a time, and then you go to extreme lengths to prove safety. You have to go through the FDA approvals. Like, we're not trying to sidestep any regulatory approvals. We're doing everything by the book, and with maximum. We're going far beyond what the requirements are of the FDA from a safety standpoint.
Mm-hmm.
And the initial devices will really just be pretty basic. It'll be about restoring functionality to people who've lost their connection between their brain and their body. So you can imagine, like, if, say, Stephen Hawking could talk or communicate as fast as somebody with a fully functioning body.
Mm-hmm.
That would be amazing. So that's like what we're trying to do. That's our first application, is to restore functionality to quadriplegics, tetraplegics, and people who've just, for whatever reason, no longer have a connection between, or have a limited connection between their brain and their body.
Mm-hmm.
And then the second application would be restoration of eyesight. So if somebody's gone completely blind, maybe even has lost the optic nerve, you can actually still directly stimulate the neurons in the visual part of the cortex. So you can give direct vision to the brain.
Mm-hmm.
And in fact, you could actually, depending upon what cameras you use, you can actually see in different wavelengths.
Okay.
Like Geordie LaForge from, like, you could, like, have that, like, I actually watched, like, an episode of Star Trek Next Generation with special effects compared to what we're used to, are like, not that great, but he's got, like, the wraparound, glasses, and he can see in different wavelengths. So you can see, like, ultraviolet, infrared, and that kind of thing. So you can actually do that. You could say, like, you could see in radar if you want.
Mm. And what's the long-term goal for it? Because I think myself and others, I think the first part sounds fine. Sounds good.
That's, like, hard to argue with.
Yeah. But long-term, I think the concern that people have is this just leading us into this dystopian transhumanist future? Where does it go? What are the ethical boundaries of it?
Well, I mean, the thing I wanted to emphasize is that it's not going to, like, sort of pounce on us overnight.
Mm-hmm.
You'll see it coming. It's going to be very slow. In fact, I really think that artificial general intelligence, or digital superintelligence, is likely to arrive before we have really advanced neural links. At least that's where the trend is right now.
Mm-hmm.
So, but ultimately, the idea would be to achieve a symbiosis between our biological mind and our kind of digital mind. So we're already kind of a cyborg if you think of, like, your phone and your computers as an extension of yourself.
Mm-hmm.
In fact, like, if you leave your phone behind, it's like you have missing limb syndrome. You're like, where did it go? So the phone is a kind of an extension of ourselves, like computer is. The various applications that we use are already an extension of self. So we are already a cyborg. It's just that the interface is with our eyes and our fingers.
Yeah.
And that interface, especially output, the rate at which we can type words into a phone or a computer, it's very slow. Our input is much better, because with the data rate from vision is, I don't know, many thousands of times, maybe 1 million times better than the rate at which we can output. So input is, like, maybe, I don't know, roughly 1 million times better than output.